we will do some programming with 2D arrays. All right, and how to pass 2D arrays to functions, and how the function can traverse the array using different forms. Okay, so for instance, if you not sure, let's take a simple 2D array. Okay, let's put 2, 3, 4, 5, 6 and 7. This is the 2 times 3 array. Okay, 2 rows and 3 columns. Even though we could perceive this as a 2D, in real life it is implemented as a one-dimensional array. It has 6 cells. If this address of this cell is F1, say, the next one is F2, F3, it goes on, F4, F5, F6, and obviously we have to map here, right? So this is also F1 address, F2, F3, F4, F5 and F6. We know how to print these values with the for loop, right? For I equal to 0 and for j equal to 0, and you can print this two-dimensional array. It's no problem, right? But if you want to print this array as a one-dimensional, you have to know how to convert this row times column format to just a one-dimensional format. It's very simple. Let me take this away. In this case, I less than 2, I plus plus, j less than 3, j plus plus, and we know, let's say, data I j, right? It's very simple to print the values. But if you want to print as a one-dimensional array, you need to convert this two-dimensional into one-dimensional. We know that, right? That is nothing but I times column plus j will get you the index to the array. For example, what is this index, 2D index of this cell? Is row 1, so this is row 0, right? Index 0, index 1, and for column this is 1, 1, right? So column is 1. I 1. I times number of columns is what? 3, right? 3 columns. Plus j is 1. Sorry, 1. That is 4. So if you go back and put the values here, 2, 3, 4, 5, 6, 7. Pause the video and see how it is, okay? I is 1, j is 1. The column number of columns is 3. This is number of columns, okay? So we have 4. So let's see how the 4 is. 0, index 2, 1, 2, 3, 4 and 5. See, index 4 is 6. Index 1 comma 1 is 6. Let's take this example here. I is 0 and j is 2, right, for this element 4. So 0 times 3 plus 2, which is 2, right? Index 2. So index 2 is what? 0, 1, 2, which is 4. That's what we got. So this mapping is what you have to do if you want to traverse as a one-dimensional array. Alright, so let's do that both ways here. I have defined a function, a very simple function, 2D array, 2, 3, and the couple of things before we get into the program. We know how to assign values in a 2D array. This is how it's done. And the one more thing we need to remember is, if I can, let me pause and copy this into the PowerPoint. Okay, I have copied. Let me go back here. I can erase this now, at least partly. Every two-dimensional, in this case, let's take example here, the same example, 2D. Every 2D in C language is actually nothing but is array of array. This 2, 3, 4, 5, 6, 7. We can consider this itself is an array of arrays. Okay, this is the first array. This is the second array. All right. So this could be a pointer up to the row 0, pointer to row 1. It goes like that. Okay, you can do that. So we will try to do that using in this function 2D array. Okay, and when you pass arrays to the any function, all right, if you see here, you have to this function defines that array. This function defines the array as 3 columns, and the rows is undefined. Then it becomes row pointers of columns. Okay, basically what we're thinking is we're defining pointers to arrays. Okay, with 3 columns in each array. That's what it is. We have 3 columns here, so that's what we're defining. And we need to tell this point function needs row and column, and basically to say how many arrays are there. Okay, so let me compile here. For I equal to 0, I less than row, I plus plus, column. Let me remove that guy. Easy. Okay, you can fast forward for a couple of minutes. I need to write this guy. My data I, j, okay, all right. So this is how I'm printing. All right. Okay, I'm going to print it now. Compile it. Okay, I not defined I. Okay, if you see here, we are printing 2 3 4 5 6 7, which is good, right? So what we did here is we just printed using as a 2D. Now we are going to print as a one-dimensional array. Let's go here. So print data as 1D. So here, if you see as a 1D, I don't need the extra dimension like we have here. So I made it as a 1D, and the same parameters will use it. All right. So we'll use the same 1, 2, 3, 4, 5, 6, 7. I'm printing as 1D. So this has to change, right? This has to change. We know the mapping times column plus j. We don't need the, all right. And if you see now, I'm printing as a one-dimensional array because I passed as a one-dimensional array. Okay, now if I go ahead and print it, this formula is same as what we talked. All right, the same as what we did here. If you go back here, same. Oh, we erased that, is it? Okay, it's I times column that we did plus j. Okay, or it may be in the PowerPoint. Okay, all right, so we have that. Let's go and print it. Oh, I had to call it, right? I'm going to printing as 1D, right? The same thing I'm passing, because you can pass whatever we want, but it's all, the key definition is here. How you are defining it as is the key. All right, pay attention to this guy. When you have two-dimensional, the last dimension, except the first, the other dimensions you have to define except the first. Becomes okay. Let me compile it. Printing as 1D 2 3 4 5 6 7, which is same as this. You see that? Now we will go ahead and print as pointers. Print as a data as a pointer. Again, same thing, but this time if you see here, I'm passing as pointer, or rather the function defines the as a pointer. It doesn't care how you define here. It insists that in some places it could define as an array, some places it could define as a pointer. It's up to you. So let's go back and 1 2 3 4 5 6. All right, now I need to change this guy pointer. It's not an array anymore, but the same offset should work, right? My if you go back here, let me print here. This, I'm going to traverse this array using a pointer, and we know how do pointers work, right? Pointer, when you have pointer pointing to the array, we know how to traverse pointer offset +1 or +2. Those are pointers and we need to dereference to get the actual value. Okay, the two steps, right? But the index is the same as what we computed before. To get the offset, all we got to do is dereference. See the difference here. See how you do here and see how you do here. Okay, this is how we dereference. Now if I compile it, now I want to keep it as print as pointer, print with pointers. Okay, so I'll oh, the one thing I forgot. We'll come to that. All right, print data as pointer. Two errors. Okay, the array is basically here. Problem is here. Okay. So we got as pointers also. Okay. So we are done traversing the array using three forms. Okay. We have passed the function defined as a 2D, and you pay attention how it is done here, and see how we printed as a 2D, as a one-dimensional array. Okay. The last one we will talk about is arrays of array, right? We have, like we talked, this 2D could be visualized as an array of arrays. Okay. That means this is an array by its, let me put it in red. This is one array, and that is another array. So this 2, 3, 4, 5, 6, 7, we will navigate them as an array and of array. Then in each array we will print the individual elements. Okay. For that, what we had like this here, like we have this data I comma j. If you remove that, or let's here, if you remove that dimension, okay, like data I, that becomes pointer to the ith index, the row. Okay, so that means data 0 is a pointer to this guy. Data 1 is a pointer to this element. Okay, so that is how your consumption you need to visualize. All right, so let's go ahead, and here I have I written the program same as what we have, print data as array of array. Okay, I have the same parameter everything is the same, and here I initialized a pointer, declared a pointer to my data. You see that, to the ith row. That's a pointer pointing to that, and I'm printing individual elements. You see that here it is I, that is the row, and I'm printing as each individual elements using the J index. Alright, the rest is the same. The rest of the things are same here. So let's print it. Two, three, four, 5, 6, 7. So we have printed the two-dimensional array in a function using various forms. Alright. So let us recap. When we print data as 2D, we have then we pass the 2D to a function. The 2D function has to can omit the first dimension. The rest of the dimension it has to know what it is. So I defined that, and I passed row here. It uses row and column to print individual elements. So this is easy. You just have to remember that you have to define that. And then I went ahead and printed the data as 1D. Here you see that it's I defined as a 1D. Whenever you pass an array, you have to know the number of columns at least, right? So that's what we used, and we use the mapping function to traverse the two-dimensional array as a one-dimensional. Okay, that is how the computer stores arrays. Then I navigated using pointer. Okay. Then I navigated as a arrays and of arrays. But here you had the only key thing is in this you have to remember is note how I omitted the one dimension, because that is a pointer. Remember, that's a pointer. So let me recap here again. Whenever you have a 2D, each could be visualized as an array, and the entire thing could be visualized as arrays of array. Okay, and when you have the 2D, if you drop the second dimension, each row becomes a pointer. Okay, basically if you print this guy, you'll get the address of this guy, basically address of the first element in each row, basically. Okay, thank you.